This integral looks scary, but with one quick trick, we're going to transform this into a much simpler integral. So immediately, I see this and I look scared, right? I am terrified, shaking my boots. So what I'm going to do is I'm trying to get this to a simpler form just by pulling out that natural log and the exponent through our logarithm rules here. So we're going to rewrite this. The integral from 1 to the square root of e, natural log of x, and this will actually become squared as we pull this out, squared plus the natural log of x all over x times the natural log of x plus 1 dx. And now we see that we have a common natural log in both terms of the numerator. So what we can do is we can actually factor that natural log out, and that's going to give us a really nice surprise here. We're going to find that the natural logs cancel in this way, or natural log plus 1 cancels because it is a common factor. So we're just going to go bam and cancel that out. And now we can actually start integrating a much simpler function here. So we're just going to rewrite this simplified 1e, and we'll just have the natural log of x over x dx. And this is a much more approachable integral. So what we're going to do is we're going to try to use a u-substitution here. And I noticed that if I take u to be the natural log of x, right, u equals natural log of x, then when you take the differential of both sides, then what's going to happen is that dx is actually going to be equal to x times du, and that x is going to cancel out the x in our denominator. So we're going to go ahead and perform the substitution, and we're actually going to have to convert the bends as well, so we'll be careful about that. But what's going to happen is going to be u over x, because the natural log is u, and then we'll do times x du. So this became that. And now we fill in our bounds. So what we're going to do is just get the value of u when x's are in value. So when x is equal to 1, u is equal to the natural log of 1 is equal to 0. And when x is equal to the square root of e, we're going to actually use the same exponent trick here, and u is going to be the natural log of e to the 1/2, because we can rewrite the square root, and then this will be 1/2 natural log of e, which is just equal to 1/2. And so our bounds are going to be 0 and 1/2 respectively. And what we can then further do is just cancel this out once again. And notice how elegant this integral has become. It's literally just power rule for a variable. And we're just going to evaluate that. So we know that this is going to be equal to u squared over 2 by the power rule. And we're going to evaluate it at 1/2 and 0. Finally, we know that, the subtraction, when we do subtraction, it's going to become 0. So we can do 1/2 squared over 2 minus, so it'll just be 0 squared over 2. And that is going to be equal to 1/4 over 1/2, which is just 1/8. And that is indeed our final answer. So to conclude, we had this really scary looking integral at the beginning, but using just a simple algebraic trick, we were able to cancel out factors and get to a much, much simpler integral, especially with the simpler substitution here. After we have a much more simpler integral, it's much more approachable to look at the problem. Even in this step, you can actually choose your what's it called, your u. You can already do a u substitution in this step by taking, say, maybe you can do natural log of x plus 1, or you choose natural log of x, or what have you, and you'll get the same result. But it's much clearer to see once you simplify the integrand and then you actually get to this step here. So I hope you guys had fun solving this integral with me, and If you guys have a different way to solve it, just let me know in the comments. Bye.